that. Anybody want to be bold and tell us one of your two sentences? What is special about a geometric sequence? They have a common ratio. I love that. And I love that you used the vocabulary term in there too. What is special about geometric sequence? They have a common ratio. How many people use common ratio in one of your sentences? Nice. Nice. How many people kind of described what a common ratio is? Maybe you didn't use that word, but remind me, what does a common ratio do? When you're writing a geometric sequence, what do you do with the common ratio over and over and over and over again? We're multiplying. So did anybody say anything about multiplying? Yeah, something maybe. What did you say? Oh, that is awesome. I love that. It uses addition. No, you said division and multiplication instead of addition and subtraction. Excuse me. Division and multiplication instead of addition and subtraction. You know, if hypothetically I were to give you a question that were asked you about arithmetic and geometric sequences, that would be an excellent sentence to include, right? Because you're kind of contrasting the two. That's awesome. Well done. Anybody else want to share anything about what they wrote for geometric sequences? Did anybody write an example down? Did anybody come up with an example? No examples? There's one right below, yeah. All right, hey, I got a challenge for you. You're going to need your calculator for this, but here's what I want you to do. I want you to start with the number 5. Can you write the number 5 down, please? And I want you to multiply it by 2, but I want you to do that 10 times. And I need you to get me an answer in your calculator. Take the number 5 and multiply it by 2, but do it 10 times. And see if you can find a shortcut. No spoilers. Don't shout out if you know what this shortcut is. But see if you can find a shorter way to do it. One way to do it would be to go in your calculator and type 5 times 2, 3, 4, 5, 6, 7, 8, 9, 10. You could type that in, but that's kind of tedious. Is there a faster way to do this? See if you can do that in your calculator. I need an answer. I want a final numerical value. I don't see people with their calculators in their hands. Have you already got an answer? Who's got a shortcut for me? What's your shortcut? Oh, for something else. I'm sorry. 2 to the 10th power. Are you using exponents? Why would we use an exponent for this? Because that's what an exponent does, right? It multiplies by the same thing over and over again. This would be much simpler to write. This is why they invented exponents, so we didn't have to write out stuff like that. I could do this much easier by doing 5 times 2 to the 10th power. 2 to the 10th power means make 10 copies of 2 and multiply them together. Right? See if you can type that into your calculator and get an answer for me. Did you have a question? If you've got one of these yellow calculators, I'll help you with how to do that. You're going to type in the number 5 and then multiply times and then 2. And then to do an exponent, you're looking for this button right here. It looks like a little upside down V. Some of your calculators, when you hit that, it's actually going to jump up and give you an exponent like this. Let me show you what the other style does. It just depends on the mode that your calculator is in. In some of them, it looks like this. It just has like a little caret in it. So those are the same thing. You hit enter, you're going to get the same answer for both. And I did not intend for this to happen, but isn't that kind of weird? It's like the same numbers. 5, 2, 10, all those same numbers are in the answer. That's like just a coincidence. That's not mathematical. Not that I know of. All right, guys, this is key. I do not want you to miss this next part. When we get to from here to the bottom of the page, this is how we're going to really understand how geometric sequences and their equations work. So we're going to start by building a table. And I'm giving you 3 facts. I'm telling you that this sequence we're going to build is geometric, which means, well, that means we're going to be using a common ratio. We're going to be multiplying. I am telling you that T0 is 5. Is this the, when I say T0, is that the first term, or the second term, or the 0th term? That's the 0th term. So that 5 should go next to the 0, right? You were right. And the common ratio is 2. What does that tell us? That tells us how we get to the next term. We're going to multiply by 2. So at the beginning, we're going to be able to do this in our head, but these numbers are going to get pretty huge pretty quickly. So 5 times 2 is 10. And then 10 times 2 is 20. Now, if I wanted to keep going, I could keep multiplying by 2 over and over and over and over and over again, but this is key. Can I get you guys to look up here? Please, please, please don't miss this. There is a quicker way to get to this, and that is to start back at that 5 that we had at the beginning and just work from there. Now, I'm not going to multiply by 2. I'm going to multiply times 2. How many times? 10 times. You okay? There's don't explode it on all over the table. There's pencils in the drawer over there if you need to grab one. Okay. So how do I get from here to here? I multiplied times 2 10 times, and we actually just typed that into our calculator. It was 5,120. Please don't keep messing with that. Okay. I just don't want ink all over the floor and the table. Can somebody give me one way I could come up with the 11th term? I could take this thing and multiply it times 2. Can somebody give me a second way that I could come up with the 11th term? A different way that I could come up with the 11th term? If I wanted to start all the way back at my 5 again to come up with the 11th term, what would I multiply it by instead of 2? I would multiply it times 2, but 11 times, right? Because we started at the 0th term, and we have to keep multiplying by 2 11 times to get there. Either way, you are going to get, someone help me out here. Get an answer key here somewhere. You guys got calculators? Help me out. What do you get for the 11th term? Someone read me some digits. 10, and then 240. If I wanted to get the 12th term, there's 2 ways I could do that. Either I could take that I just got, multiply it by 2, or I could go all the way back to the beginning and multiply it times 2 to the 12th this time. I'm going to go with the second option. I'm going to go back to 5 and multiply it times 2 to the 12th power. Is this the same answer you're getting if you just got it by multiplying by 2? Is that what you guys got? All right, so please use your calculator. These numbers are going to get really big to find the 15th term. You're going to start at 5, and you're going to multiply times 2, but 15 times. And then do the same thing to come up with your 20th term. Remember, we're always starting at 5 and multiplying by 2 to a power, and that power is just whatever term number we're looking for. I hope you guys are punching numbers in your calculator, not just copying down what's on the screen here. You guys actually typing these in? Let me know if you need any help with the calculator part. How to do it on that one? Yeah, can I borrow that? Because there are a couple other people who have those. A couple of you have this style of calculator. This is the other kind of common one. I'll show you how we type this in here. So I'm going to do the 15th. So I'm going to start with 5. We always start with our 0th term. Times 2. And then same button. I'm looking for this little upside down V. So I need 15th power. And that's it right there. So I'm going to clear it out. I want you to type it in yourself. Make sure you're getting that same number. Thank you for asking. All right, we coming up with the same values here? You guys are doing great. All right, these next few questions are going to build us up to writing equations for these things. So please, 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 let me get your attention again. Does anybody need a moment before we move on? All right, answer me this question. What did you multiply 5 by to get your 10th term? Times 2 to what power? To the 10th power. And what did you multiply 5 by to get your 15th term? So 2 to the 15th power, right? And what did you multiply 5 by to get your 20th term? By 2 to the 20th power. Now, we didn't do the 42nd term, but if I wanted to find the 42nd term, I would multiply 5 times 2 to the 42nd. Now, our goal here today is to write an equation that doesn't say t of 20 or t of 42. We want t of n. And if we follow this pattern, what do you suppose we're going to have over here? 5 times 2 to the n power. And this is the format for our geometric sequences. Okay? Flip over onto the back side here. I got the format filled in here. Go ahead and put the numbers in that we just did. We had 5 and 2. When you write a geometric sequence, there are 2 pieces. There are 2 numbers. Remind me, what was special about 5 in that problem we just did on the front? It was the 0th term. Let's take notes and label that. 5 was the 0th term. Sometimes we write that as T0. And what was special about 2 in that problem that we just did on the front side? It was the common ratio. And I'm going to give you another name for this that we're going to end up using when we get to chapter 7. Sometimes we call this the multiplier. Do you see why we might use that name as well? Because it's the thing that we're multiplying by over and over and over again. So let's see if you can do this. If I give you the 0th term of a sequence and what the common ratio is, can you write me an equation? What do you think? It's going to be in that format. You just got to get those 2 numbers in the right spots. Give it a shot. See what you can do there. Try it on the next one also. You just need to get those 2 numbers in the right place. The format's going to be the same for both of these because they are geometric sequences, and that's what an equation for a geometric sequence looks like. So 0th term comes first. Common ratio is the thing with the exponent on it. 0th term comes first. Common ratio is the thing with the exponent on it. All right, what do you guys think about writing these equations? These are kind of new. They don't look like our y equals mx plus b style equations that we've been writing, do they? So we're going to use these a bunch, again, in 2 chapters. When we get to chapter 8, we're going to be writing exponential equations, and they're going to have the same format. So by the end of this year, you're going to have two kind of key types of equations you're going to know really, really well. Linear equations, the ones that look like y equals mx plus b, and exponential equations that look like these. For right now, though, let's just focus on our geometric sequences. So look down at the bottom of the page. This is our ultimate goal. I want you guys to be able to do these 4 problems on your own. Okay, I'm not going to go over how to do these 4 problems at the bottom, but I'm going to walk you through this one up here, step by step. If you can understand all of the steps to do this one up here, you'll have no trouble with those 4 at the bottom. Okay, so follow along with me. Ask some questions if something doesn't make sense to you. All right, look at this sequence. This is a different one from the one we were just dealing with. And tell me, can you find the common ratio? Are you guys feeling comfortable finding the common ratio? Kelly, you explained to us how to do that just a minute ago. You said do the second term divided by the first term, or the third divided by the second, or the fifth divided by the fourth. You can pick any one you want and divide it. So please pick up your calculator and do that for me. You could try doing 972 divided by 216. That's the second divided by the first. Type that in your calculator. I'm not going to do it for you. You guys all got calculators in front of you. Or you could do 4,374 divided by what came before that? 972. You should get the same answer if you do both of those, because it's a common ratio. Common ratio means that they are in common. Have you tried it? Did you get a ratio for me already? You didn't get this? Did you type this in your calculator yet? 4.5 is right. For the second one, it didn't come out the same? Oh, uh-oh. That makes me worry that I might have a typo. I'm gonna double check. Nope, it's 4.5 also. And did anybody try it with like these 2 big numbers? I did earlier. It comes out to 4.5 also. So that's our common ratio, 4.5. That's good. We're going to need that to write our equation in a second. The other thing that we need is the 0th term. Now, is this the 0th term? Is 216 the 0th term? No, that's the first term. This is the second, third, and fourth. We need the 0th term, which would come before the first term, which means we need to work backwards. To go forwards, we're multiplying by 4.5. To go backwards, we have to do the opposite. What is the opposite of multiplying by 4.5? We're going to need to divide by 4.5. So take that 216, that's your first term, and divide it by 4.5 using your calculator, and that's going to get you your 0th term. So we're going backwards by dividing by 4.5. 216 divided by 4.5 is 48. That would be our 0th term. All right, you now have everything you need to write the equation, so go ahead. All you need to do is get those 2 numbers in the correct spot. You've got some notes up top to remind you which number goes where. Can you get that 4.5 and the 48 in the right place? This will be the part that's really easy to flip these around. So really focus today on trying to come up with a way to help you remember what goes where in these equations. What's going to go in my first spot here, the 4.5 or the 48? The 48, that's our 0th term. The 0th term goes first. And then the thing with the exponent is our common ratio. That's our 4.5. All right, how are we feeling, guys? Can you look up here for a second? This is going to be also really important. One of the things I love about math is that when you go in to take a test, you can usually check and make sure that your answer is right before you leave. We've talked about how to do that with systems. I'm going to show you how to check these answers. And I hope that you guys will pay attention because, again, you're about to take a big test on this, right? And so it would be nice if you've got some extra time to check your work and see if you made any mistakes, because we all make them. Can I get your attention? People are working ahead, and I don't want you to miss this, please. We're going to test our equation, okay? And I'm going to remind you to do this on the test too, but Here's what I'm going to do. I'm going to ask you, can you please use your equation, this equation right here, to find t of 3? Let's pretend we don't know that it's 4,374. Let's pretend that we don't know that. That is t of 3, isn't it? That is the third term is going to be this. But I want to use this equation and make sure that it comes out to that same number. Could you please write this down? According to our equation, T3 should be 48 times 4.5 to what power? To the third power, right? Remember that number is the thing that replaces the n. Can you all right now type that into your calculator? 48 times 4.5 to the third power. And see what your calculator says. Mine says 4,374. Does that make me feel good about my equation? Does it match up with what was in our sequence? Yeah. Try doing the same thing for the fourth term, T4. Using our equation to find T4, we would take our equation, 48 times 4.5, except this time, what are we going to put in place of the n? We're going to put that 4 in there. Type that into our equation, and we're hoping it comes out to be equal to 19,683. If it does, that means our equation is matching up with the original sequence. 48 times 4.5 to the fourth power is, yep, that's it. So do these values match our given sequences? Yup. And that makes me happy. All right, your job right now, if you haven't done so already, is to do these 4 problems down the page. Before we part ways and I cut you loose, what questions do you have? Yeah. Is it about one of the ones at the bottom? Okay, I'll come around and answer those individual questions in a minute. Any questions about any of the work that we've done today, guys? I'm going to put answers up on the board here, but I don't want you to just copy them. Please work the problems out and then look up and check when you're done. When you're finished, you guys see where I'm pointing right now? See over by the window there, you see that stack of papers? That's your assignment. So when you're finished, go over there and grab that, okay? You do not need to turn in these notes. In fact, I want you to stick them in your folder and hang on to them. We're going to come back on Tuesday and we'll be using these. All right, you guys did a great job. Go ahead and finish those last 4 problems. Check with me if you have any questions or if you don't feel like you're getting right answers. Again, I'm putting answers up on the screen, but please don't just copy these. Try and do the problems yourself and then use this as an opportunity to check your work.